Hi and welcome back to Schrodinger's classes. Today we'll be dealing with comparative statics. I'll be starting from the very beginning, from the basic, and we'll go on to much alleged harder sums. Let's do. A function is given y equals to fx and is said it is discontinuous at x equals to x naught when any of the three requirements for continuity is violated. I'll show you three graphs to illustrate this violation of those requirements. Now I have drawn three individual graphs. In the first graph, notice that x is discontinuous at this point. Thus, it violates our condition for continuity. Next, although the value for each x can be obtained in the second graph, notice that the value is not at all continuous. It starts and ends out here, and again it starts and ends. Thus, there is a value gap between this. Next, the third condition is that the graph starts here, then the value that is obtained of this axis, that is, let us assume y, has a point x, and then again it starts from here. This again violates all the requirements for continuity. Let's move on to our next question. Let's do a question. In this it said that set of all finite real numbers as the domain of the function, let me erase it for you. Q equals to gv equals to v square minus 5v minus 2. We have to find the limit of q as v tends to n. Please pause the video and try it on your own, because I'm gonna do it in just a while. Now the limits will be limit v tends to n, q equals to n square minus 5n minus 2 equals to g n. It was simple. Did you try it on your own? Doesn't matter. Let's move on to the next question. B. Check whether this limit is equal to g n. What do you think? Yes. As we see, this limit is equals to g n. Upon solving, you'll find that this is the answer that you get. Lastly, we need to check whether the function is continuous at n and continuous in its domain or not. You can try it on your own. I'll give you the answer in a while. The answer is yes for this one too. You can try it and submit it in the comment section below. Let me see how good you are. We have a new sum. Let's try it out. We are given this function y equals to fx equals to x square minus 9x plus 20 by x minus 4. Now firstly, is it possible to apply the quotient limit theorem to find the limit of the function as x tends to 4? What do you think? Well, the answer is a no. This is because as x tends to 4, this slowly tends to become undefined. Thus, we cannot answer it into the quotient limit theorem. Next, we are asked, is this function continuous at x equals to 4? No, because fx is not defined for x equals to 4. And lastly, we need to find whether the function for which x not equals to 4 is equivalent to the given function or not, and obtain from the equivalent function the limit of y as x tends to 4. For x not equals to 4, the function reduces to y equals to x minus 5. So limit y with x tends to 4 is equals to -1. Now we have a similar question just for your practice. We're going to be doing q equals to gv equals to v plus 2 by v square plus 2. We need to use the limit theorems to find limit v tends to n q, n being a finite real number. Let's see how to do that. Try it on your own because I'm going to show the answer in just a minute. Here limit q where v tends to n equals to n plus 2 by n square plus 2 equals to gn. This answers are number B, that is whether the limit is equals to gn or not. Now let's check the third one, the continuity of the function gv at n and its domain minus infinity to infinity. Upon inspection, we find that the function is continuous in the domain. To find out, check any value, put it in this function and check whether it exists in the domain or not. If any of the value does not exist, the function is not continuous in the domain. Choose a random value, repeat the process and check for 2-3 values. Or you can use the normal theorem that is applied. In the next video, we'll be continuing with comparative statics. We'll be seeing rules of differentiation and other such uses in the field of comparative statics. We'll be seeing much difficult question that usually students face problem with. Please press like, subscribe to our channel and press the notification button down below. Thank you and we'll meet you soon.